Welcome to my channel. In this session, we will discuss the properties of medians in triangles and then apply these properties and answer a couple of questions. This is the ninth in the series of geometry videos that we are making. What is a median? If you look at this triangle, let's say if D, E, F are the midpoints, this AD is a line segment that is joining this midpoint and opposite vertex, or this BE is the line segment that joins the midpoint of this AC and BE. Similarly, CF is a line segment that joins the midpoint and opposite vertex. So the line segment that joins a midpoint of a side and the opposite vertex is called a median, right? So AD is a median drawn to the side BC, CF is a median drawn to the side AB, B is the median drawn to the side AC. And like we discussed in the previous session on altitudes, in a triangle, the longest side will have the shortest altitude, the shortest side will have the longest altitude. Here also, the longest side of a triangle will have the shortest median, the shortest side will have the longest median. The median to the longest side is the shortest one, and conversely, the median to the shortest side is the longest one. And when we draw a median in a triangle, it divides the triangle into two triangles of equal area. For example, if I take this AD is dividing this triangle ABC into two triangles ABD and ADC of equal area. These areas will be equal. The reason why the areas are equal, students, is because BD and DC are equal because D is the midpoint. In this triangle ABD and triangle ADC, BD is the base here, DC is the base, the bases are equal. They both have the same third vertex, means bases are on the same line. Both triangles have the same third vertex, means it means the height of the two triangles is same. If the base is same and height also is same, means areas will be equal. Similarly, when you draw BE, it is divided into two triangles of equal area, ABE and EBC, the areas will be equal. Or when I join CF, so this ACF and CFB both are of equal areas. And when you draw all the three medians, they will meet at a point. That point is called centroid. This G what I have written is the centroid. What is centroid? What are its properties? We will discuss in one of the following sessions. But now, when you draw all these three medians, you can see the given triangle is divided into 1, 2, 3, 4, 5, 6 triangles, and these 6 will be equal in area, or any one triangle is going to be 1/6 of the triangle ABC, right? So each triangle is 1/6 of ABC. The next point is, how do we find the length of the median? If I want to know what is AD's length, how do we know? In terms of the three sides. See, if AD is a median drawn to BC, so if the equation is this, there is a theorem called Aplonious Theorem which says like this: 2 into it is drawn to a side, AD is the median we are trying to find out, 2 into AD square plus, which is, it is drawn to which side? BC. Take half of BC. You can take BD, or I can say DC, both are same, or you can write simply BC by 2 whole square, because BD is nothing but half of BC, equals to, from which vertex we are drawing? From A, that's adjacent sides AB and AC, AB square and AC square. This is called Aplonious Theorem. You can see 2 into AD square plus BD square, that is half of BC square, equals to AB square plus AC square. If I draw the other median BE, 2 into BE square plus it is drawn to AC, half of that, that is AE square, equals to, from which vertex? From B, BA, that is AB square plus BC square. Similarly, the third one, 2 into CF square, it is drawn to AB, half of AB, that is AF square, equals to CA square, that is AC square plus BC square. So this is how we draw. We try to find the median length using this Aplonious theorem. Now, when we add all these three equations, see, this AD, BE, CF are the medians. AB, AC, BC, these are the sides. This BD can also be written as BC by 2. AE can be written as AC by 2. AF can be written as AB by 2. So we can establish the relation between medians and sides of a triangle. And that relation will be this. When you simplify these three equations, we get 4 times of AD square plus BE square plus CF square will be equal to 3 times of AB square plus BC square plus AC square. That is 4 times sum of the squares of the medians equals to 3 times sum of the squares of the sides. This is the relation between medians and sides of a triangle, right? Now the special triangle, that is right angle triangle, if you consider, in this right angle triangle, right angle is at B, so AC is hypotenuse, D is the midpoint of AC, means this BD is the median drawn to hypotenuse in a right angle triangle. In a right angle triangle, median drawn to hypotenuse is half of hypotenuse. That means here this BD equals to half of AC, right? So these are few important points on medians. We'll apply these points and try and answer a couple of questions. The first one, find the length of the median drawn to a side of 20 centimeters in a triangle whose other sides are 12 centimeters and 16 centimeters. I'll explain this question in two different ways. First one, if you are a little alert, you can identify that it is a right angle triangle. 12, 16, 20, are they not sides of right angle triangle? One of the triplets we spoke about right angle triangle is 3, 4, 5. Is it not 4, 3 is 12, 4, 4, 16, 4, 5 is 20? Now so the largest side is the hypotenuse. So the 20 is going to be the hypotenuse. If I take this is 12, 16 and this is 20. I want a median drawn to the side of 20 means, in other words, I am asking median drawn to hypotenuse. Median drawn to hypotenuse is half of the hypotenuse. That is, half of the hypotenuse means it is 20 by 2. 10 is our answer. Our answer is 10. It's as simple as this. If you identify it as a right angle triangle. If you are not able to identify it as right angle triangle, then it will take a little more time. You can see the difference between identifying a right angle triangle or not identifying it. Suppose if I say ABC is a triangle, 12, 16 and 20. Now I want median drawn to side 20 means if I draw a median, so this will be the midpoint. So BD will be 10, DC will be 10. If I apply the Aplonious Theorem, 2 into AD square, which I have to find out, plus this BD square will be 10 square equals to, see, 12 square plus 16 square. So 2 into AD square plus 100 equals to 12 square is 144. This is 256, 400. It will be 200. This 100 goes other side. AD square equals to 100. AD equals to 10. We'll get the answer, but it requires some calculations. Whereas here it is very simple. So the key is, whenever you are given three sides, identifying whether they are the sides of right angle triangle. Done? Let's take up one more question. In a triangle ABC, the medians AD and BE intersect at P. Find the ratio of area of quadrilateral CDPE to that of triangle ABC. If you take this triangle ABC, D is the midpoint if I assume here, AD is a median, BE is a median. So now they intersect at P. We know that medians meet at the centroid. Now we need to find the CDPE's area to ABC's area, triangle ABC's area. Now we have drawn two medians. If I draw the third median, let us say from C to AB, that also will pass through P. All medians will concur at a point, that's called centroid, I said. So we will discuss about centroid later. So the third median also will go through this P, let us say CF. When we draw all the three medians, the given triangle is divided into 6 triangles and we discussed all 6 are equal in area. Now tell me this CDPE consists of how many triangles? It consists 2 triangles. ABC consists 6 triangles. So 2:6, the ratio is 1:3. Is as simple as that. So the key, students, is just joining one extra line, you will get the clarity, right? So these are a couple of questions on medians, and In the next session, we will take up angular bisectors. Students, for more on geometry for a comprehensive course, please reach my profile at Udemy. The link is given below in the description. You find a course there, a comprehensive course for geometry there. Thank you.